Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Arabinose is an aldopentose, 5-carbon sugar with 3 stereocenters C2C3C4. The L designation is determined by the configuration at the highest numbered stereocenter, C4. If the OH at C4 is on the left in the Fischer projection, the sugar is L. Moving on to the next step. L-arabinose is the mirror image of D-arabinose. D-arabinose has the configuration C2 OH right, C3 OH left, C4 OH right in Fischer projection. Therefore, L-arabinose has C2 OH left, C3 OH right, C4 OH left in Fischer projection. Written from top to bottom, show C2 O on left, H on right, C3 H on left, O on right, C4 O on left, H on right. Wait, let me rederive carefully. Moving on to the next step. Show C2 H left OH right, C3 OH left H right, C4 H left OH right, CH2O. So D-arabinose is equal to 2R, 3S, 4R loosely, with OH at C2 right, C3 left, C4 right. And for the final step, OH at C2 left, C3 right, C4 left. Fischer projection from top, show C2 OCH, OH left, C3 HCO, or right, C4 OCH, OH left, CH2O. Option C shows CHO, then HCO, C2 OH right, then OCH, C3 OH left, then OCH, C4 OH left, then CH2O. C4 OH is on the left, confirming L series. This matches L-arabinose configuration, C2 OH right, C3 OH left, C4 OH left, which corresponds to L-arabinose as derived from standard sugar tables. Option A. C4 has OH on right D series. This is D-xylose or similar. Option B. C4 has H on right, OH left, but C2 and C3 pattern doesn't match L-arabinose. Option D has 4 stereocenters shown. CHO plus 4 carbons plus CH2O is equal to hexose, so it's a hexose not a pentose, making it irrelevant for arabinose. Therefore, the correct answer is C. Therefore, the correct answer is option C.